So today we're going to talk all about reference angles. We're going to talk about the definition, what is a reference angle, and then we're going to see, okay, now that we know what these things are, how are they useful to us? And reference angles are going to show up a lot, and they have a lot of uses. They're really like a utility thing. All right, let's get going. So the definition of a reference angle. The definition: the reference angle is sometimes called related angle for any angle theta in standard position is the positive acute angle between the terminal side of theta and the x-axis. So the x-axis is here, right? So what does that look like? That means if I have an angle out here, right, and let's say that theta was equal to 120 degrees, right, which would put theta out here, that means that the reference angle is the angle here from where the terminal side of the line is and to the x-axis. So if theta is 120 and we know that the axis line is 180, then my resulting angle here would be 60. My reference angle would be 60. So let's look at that again. Suppose I had an angle, coming out here, and let's say theta was equal to 330 degrees, which is also something really common, we'll see. Well, if theta is 330 and all the way around is 360, well, my reference angle is always, okay, what's the angle between the x-axis and my angle? So always, 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 it's between the x-axis and the terminal side. So wherever your angle ended up, okay, the angle that's formed between the terminal side and the x-axis. So if this angle was 330, well, all the way around is 360. That means that my reference angle must be 30 degrees. So let's do some more explicit examples. So what is the reference angle for, and let's say theta equals 315. Well, where does 315 put us? Well, we know that that's 0 or 360. We know that's 90. We know all the way here is 180. We know that this is 270. So 315 is going to put us somewhere over here. So we've opened up here. Theta equals 315 degrees. So what's my reference angle then? Well, my reference angle is the angle that the terminal side makes with the x-axis. Okay, well, I know this is 360 degrees, and I've already gone 315 degrees, right? So all we're doing is just a simple subtraction. Hey, what's 360 minus 315? And that's how we'll figure out the reference angle. And in this case, it's 45 degrees. Okay, what about if I had theta equals negative 135 degrees? Okay, well, that's a negative angle. How do I do that? Well, remember, negative angles, they just open downwards, right? So now that's still my 0, but now that's 90, that's 180. So negative 90, negative 180. So my negative 135 is living in here, right? And we opened downwards. Okay, so what's my reference angle? My reference angle is still the angle that the terminal side made with the x-axis. Okay, well, how do I figure this out? Well, all the way around would have been 180. I went 135. Even though we're going in the negative direction, it still works this way. Okay, so what's the space in between? So let's do some subtraction. So what is 180 minus 135? In this case, you'll see again, we get 45 degrees. Okay, so also the same reference angle. So to find reference angles, it's just, hey, am I doing 180 minus my angle, or am I doing 360 minus my angle? So let's do one more, and I'm going to really change things up here. So what if we had, now I'm going to put theta in terms of degrees and minutes. What if we had theta equaling 225 degrees and 10 minutes? So I'm switching up the unit of measurement here. So 225 degrees though, right? 0, I'm opening now positive. 0, 90, 180, 270. So I'm not all the way down there yet. So I've opened positively 225 degrees, 10 minutes, right? Okay, so I'm still going to play the same game. So how far, though, is that angle from the x-axis, right? What is this? Well, this space here is still 180, right? And I went 225, 10. So I'm just still going to do a subtraction. I want to find the space between here and here. So I'm going to subtract this space from this space, and I'll get the in-between space. So 225 degrees, 10 minutes, minus 180, and there's 0 minutes there because it's a perfect angle. So we would still get 10 minutes here, and 225 minus 180 is going to be, sorry guys, copy hasn't quite kicked in yet. Ah, yes, of course, it's our favorite angle, 45. So this would be 45 degrees, 10 minutes. Okay, so again, how to find reference angle. Take wherever your angle is, quadrant 1, 2, 3, or 4. Find the distance between the terminal side of your angle and the x-axis. So find the angle formed from the terminal side to the x-axis. That's it. That's your reference angle. So now let's see how to use it. So there is a theorem, a trigonomic function of an angle and its reference angle differ at most in sine. So how does that help us? Well, suppose I wanted to do something like take sine of 330 degrees. Well, how would I know what that is exactly? I could plug it into a calculator, but you know, what if it's one of those square roots and I don't get a nice number and I really want to answer this exactly? Or what if I've lost my calculator? So sine of 330, well, we're going to use the reference angle to solve this. So 330, 0, 90, 180, 270, so 330 is over here. So this was 330. Our reference angle now, our reference angle is 30 degrees. So what this means is, it means the value of sine of 330 and the value of sine of 30 differ at most by sine. So what am I going to do here? I'm going to recognize that I'm in quadrant 4. And where is sine positive and negative? Well, sine is positive, positive, sine is negative, and negative. So I know whatever my answer is, I need to get a negative number. So instead of taking sine of 330, I can take sine of the reference angle, and I just have to keep in mind that I'm in quadrant 4, and my answer needs to be negative. So what is sine of 30? Well, sine of 30 is 1/2, right? We know this from our trig functions of special angles. Sine of 30 is 1/2, and because I'm in quadrant 4, then I will use negative 1/2. And how to use reference angles to find trig values exactly. So let's do another example. Make sure I hit all of this with my eraser. Oh, missed some. Okay, what about tangent of 120? Remember, the only special angles we've been given so far is we know 30, 45s, and 60s. We also know 0s and 90s. But I wasn't given a 120. So let's see how to do this. So 0, 90, that's 180. So it exists somewhere between in here. So I know that theta here is equal to 120. Okay, so what is my reference angle then? So my reference angle, so if I went 120 and all the way is 180, 180 minus 120, my reference angle then would be 60. I am in quadrant 2. If I'm in quadrant 2, what is the sign of tangent supposed to be? Well, tangent is positive in quadrant 1, it's negative in quadrant 2, positive and negative. So I know I'm supposed to get a negative answer here. So tangent of 60, again, reference those special angles. Tangent of 60 is root 3, and I'm in quadrant 2, so I need to use negative root 3, okay? So use your trig functions of special angles and then make sure your sign matches depending on what quadrant you're in. And then you can use your reference angle and you don't have to worry about knowing what tangent of 120 is because you know what tangent of 60 is, and that's just as good. So let's do one more example. I'm going to kind of do a challenge one. So last example, this is really going to bring everything home. What if I wanted to find secant of 690 degrees? Well, first off, notice that 690 is more than 360, right? So 690 is I'm going around once, that's 360, and then I'm going around another 330, and I end up here. So this is 690. Notice the terminal side though, right? I have a coterminal angle here. I can just subtract 360 from this, and this is going to be the same as secant of 330. I subtract 360 from 690, I get 330. Now I have something I really rather play with here. So if you have a large angle or a large positive or large negative, just subtract down your 360s until you get a coterminal angle that's between 0 and 360, because they're much nicer to play with, right? So I'm just going to use my coterminal angle because coterminal angles are equal. So I'd rather use that, so that's what I'm going to do. So now I'm going to mess with my coterminal and let theta equal 330. Okay, so first piece of the puzzle is kind of taken care of. I'm again going to use my reference angle. Well, if theta was 330 and all the way around is 360, 360 minus 330, my reference angle is 30 degrees. Okay, well, I have another issue here. So I'm using secant, right? But my value of trig functions only tells me sine, cosine, and tangent. So what could I do with this? Well, secant is 1 over cosine, right? So this guy is equal to 1 over cosine of 330. Now I'm getting somewhere. Okay, cosine I can do something with. So cosine, I'm in quadrant 4. My cosine is positive, negative, negative, positive. Okay, so I know my answer needs to be positive. So let me continue over here. So cosine of 330 is the same as cosine of 30, and I need my answer to be positive. So this is the same as 1 over cosine of 30 is root 3 over 2. And because I'm in quadrant 4, it's staying positive. Again, this is how I know that this is positive, because I'm in quadrant 4 and cosine is positive in quadrant 4. 1 over this, take the reciprocal, 2 over root 3. Let's rationalize. So get that root out of the denominator. So this would be 2 root 3. Root 3 times root 3 is 3. And this would be our final answer here. And then we're done. So how we used reference angles, we even brought in some coterminal angles. We use our trig functions of special angles for this as well. And now we were able to answer everything exactly, and we never even needed to bring in a calculator. So this is the really special value of reference angles. So I hope that helped, but as always, if you have any questions, please don't hesitate to ask, and I'll see you guys next time. Bye.